Hello friends, welcome to my video. Today I am going to talk about covariance and contravariance in C#. It's important concept and little tricky to understand. In this video, we'll learn what covariance and contravariance in C# are, and then we'll see how these two give us the flexibility when we deal with the class definition hierarchies and assignment compatibility. Later, we'll see how these two enable implicit reference conversion for arrays, delegates, and generic types. So before we get started, just a quick reminder to subscribe my channel, hit the red button, and don't forget to click on the little bell icon. That way you will be notified every time I upload a new video. Okay, without any further delay, let's get started. What are covariance and contravariance in C#? First, we understand co and contra prefix meaning. The co prefix means together with, and contra prefix means against something. Covariance preserves assignment compatibility between parent and child relationships during dynamic polymorphism or object substitution. Contravariance is the opposite of the covariance. In other words, covariance is the assignment of a child type to its parent type, whereas contravariance is the opposite of the covariance, that is passing of the parent type to child types. In C#, covariance and contravariance got extended, and now it enables implicit reference conversion for the following types as well. So what are those types? Those types are array types, delegate types, and generic types. Before jumping into covariance and contravariance concept, let's first understand the parent and child relationship. Before jumping into covariance and contravariance concept, let's first understand the parent and child relationships. As we know, parent class is treated as a base class, where it has its own functionalities. When we create its child class, so child class inherits the parent class functionalities, and we add some functionalities in child class also. So child class has its own functionalities plus the functionalities of its parent. Thus, child class can be considered as a huge one compared to its parent, right? Okay, now let's see the example shown over here. Here there are two classes, parent and child class. Parent class has one method named parent method that simply print a statement getting executed inside the parent method into the console window. Similarly, child class has child method that prints a statement getting executed inside the child method into the console window, right? Okay, now if you see right hand side where I wrote the class instantiation, here I have written parent obj1 is equal to new parent. So here basically what I'm doing, I'm assigning the parent class object to parent class reference. So that's why it's a valid one. Now if you see the second statement, parent obj2 is equal to new child, which is also valid. Here what I'm doing, I'm assigning the child class object to a parent class reference. Now if you see the third statement, child obj3 is equal to new child, that is also valid because I'm just assigning the child class object to a child class reference. Now let's see the fourth statement, child obj4 is equal to new parent, which is invalid. Here I'm trying to assign the parent class object to a child class reference, which is invalid. Why? Because requirement is for the huge functionality and less functionality is getting assigned. In this case, child class own functionality is hidden, even though we are using child class reference. That's why C# creator made this as invalid. And if you write this, IntelliSense starts showing the red underline of the new parent shown over here, right? And if we ignore and compile it, we end up getting compile time error, which is typecasting error that's shown over here. Now, when we create the object of this class, we can take help of its object and call its method, right? And that's what these statements I have written. Now, if you notice the first statement where I have written obj1.parent method. As obj1 is an object of parent class, so we can call its method. That's why this is valid to write. If you see the second statement, obj2.parent method. Here obj2 is the parent class reference that is carrying child class object. So it's calling parent method. However, it can't call child method as it is hidden and not accessible for him. Now let's see the third and fourth statement where I have written obj3.child method, obj3.parent method. Here obj3 is the child class reference that is carrying child class object itself. So it can call its own method and its parent method is. And that's why these two statements are valid to write. And if you see the output, we are getting the expected one, getting executed inside the parent method, getting executed inside the parent method, getting executed inside the child method, getting executed inside the parent method, right? Let's switch to the Visual Studio and see all these things in action quickly. Okay, so here we are on Visual Studio. I have created one console application named Covariance and Contravariance that has program.cs file. In program.cs file, we have three classes: parent class, child class, and the program class. Child class is inheriting the parent class. And parent class has one method, parent method, and this method is just print this statement into this console window. Similarly, child class has child method, it prints this statement into console window. And program class has the main method, which is an entry point of this application. So here we are doing the initialization of the class. If you see here, parent obj1 is equal to new parent, parent obj2 is equal to new child, child obj3 is equal to new child, and these three statement is valid to write the part of the class instantiation. But if you see the fourth statement, child obj4 is equal to new parent, it is invalid. And let's see if I uncomment this. So if you see here, this red underline got appeared over here, and when I over it, it is giving me error. Cannot implicitly convert type demo.parent to demo.child, and explicit conversion exists. Are you missing a cast, right? So that's what it is invalid to write. So let me comment it again. Now, if you see this obj1 is nothing but object of this parent class. So we are able to successfully access this parents method. Similarly, obj2 is a reference of parent class, but it holds the object of the child. But if you see here, I am able to access only the parent method. If I just click dot over here, so only the parent method is visible over here. We are not able to see the child method, even though this obj2 is carrying the child object, but it is a reference of the parent, right? That's what we are not able to see child method, and that's what we are not able to use that. Okay, now come to the child obj3 is equal to new child. Here obj3 is nothing but the instance of the child class, right? And because the child class is inheriting this parent class, so it has access on this parent method and the child method, and that's what we are able to call this obj3.child method and obj3.parent method. And if you write dot over here, so it give me both parent method and the child method all together, right? So we are able to access both the methods. So that's what the relationship of the parent and child. Okay, let me execute this and see the output. Okay, so output got appear into this console window. Okay, if you see here, the first method call obj1.parent method. So this parent method got invoked and this statement got printed, and that's what we are able to see the first statement over here. Similarly, obj2.parent method, this parent method got invoked and the second statement is getting printed over here, right? And the third one, child method. So child method got invoked, this statement got printed, getting executed inside the child method. And obj3.parent method, so this parent method again got invoked and this statement got printed into this console window, and that's what we are able to see these four statements over here. So now we have understood how that parent and child relationship works, right? Now we have fair idea about parent and child relationships, like how we can do the class instantiation in child parent relationships in different combination as per the requirement. What is valid, what not valid, where the functionalities are hidden, where it is visible, right? So let's understand the concept of covariance and contravariance now. Here I have written the example of covariance and contravariance in order to understand it. If you see the covariance example shown over here, here there are two classes, parent and child class. Child class inherits the parent class. Parent class has parent method and child has child method. Now I have created the object of these classes where class reference is carrying same class object itself, and that's what I have written. Parent obj parent is equal to new parent, child obj child is equal to new child. Now I have written obj parent is equal to obj child. Here what I am doing, I am assigning the child object to the parent object, and C# allows this implicit conversion, that is child to parent. This is nothing but the covariance, where implicit conversion takes place on reference types without explicit casting. Hope now you must have understood what covariance is, right? Okay, now let's see the contravariance example. Here I have written obj child is equal to obj parent. What I'm trying to do over here is I'm trying to perform opposite assignment as per the definition of the contravariance. But I end up getting error, like no implicit conversion for parent to child. Why I got this error? Because contravariance applies more to the parameters instead of the object or variables. And here I'm trying to do at the object level, right? Okay, now we'll see covariance and contravariance concept with arrays, delegates and generics one by one and take a deep dive on it. Covariance and contravariance with arrays. Covariance in C# arrays is not always type safe. So let's try to understand covariance with C# arrays from the example shown over here. So here there are three classes: parent class, male child class and female child class. Male child class and the female child class inherit the parent class, and that's what I have written: class male child colon parent, class female child colon parent, right? So parent male child and female child class has parent method, male child method and female child method respectively. Now there is a male child array named obj male child array that contains the male child object. Then there is a parent array named obj parent array where I am assigning the object of the male child array. So that's the covariance where implicit conversion is happening, but it is not type safe. Okay, because when we try to write something like this, obj parent array is 0 is equal to new female child, we end up getting error array type mismatch exception error at runtime because obj parent array was dedicated for the male child and we are assigning the female child over here. That's why error type mismatch exception error occurred. That's what it's not a type safe. So what safe approach would be? Safe approach is to use IEnumerable. So we need to write something like this: IEnumerable parent obj parent array equal to obj male child array. So here covariance is happening, but with the safe approach. And when we write something like this, obj parent array 0 is equal to new female child, so we get the error indicated by the IntelliSense itself. And if we ignore, we get to know the invalid assignment at the compile time itself instead of runtime, because IEnumerable is the read only, so no more element assignment allowed. Coming to the contravariance, contravariance on the array is not supported in C#. If you write something like this, parent obj parent array is equal to new male child, and when we try to assign the parent array object to the male child, we end up getting invalid cast exception at runtime. So C# does not support contravariance on the array. Clear? So here we are on Visual Studio. Here we are going to see the demo of the covariance and contravariance with array. Okay, so for that I have created one console application, covariance and contravariance, that has program.cs file. In program.cs file we have four class parent, male child and female child, and finally we have this class named program. So parent child class is having parent method, and basically it prints this statement: male child and female child inherit the parent class, and it has male child method and the female child method. In main method there is a male child array named obj male child array that contains male child object, and then there is a parent array named obj parent array, and where I am assigning the object of the male child array. So that's the covariance where implicit conversion is happening, but it is not type safe, right? Because when we try to write something like this, obj parent array is equal to new female child, we end up getting error array type mismatch exception at runtime because obj parent array was dedicated for the male child, and here we are assigning the female child. So I just put the breakpoint over here. Okay, now let me execute this and see the output. See, here the control came. Let me click F10. Okay, so if you see here, this system.array type mismatch exception occurred, right? This statement gave this error, and that's what we cannot write like this because it's not safe. So what the safe approach would be? Now I have commented this. I have written the safe approach where I have used the IEnumerable. So that's what I have written: IEnumerable parent obj parent array is equal to obj male child. And if you are going ahead with the assigning this, female child, it is giving me IntelliSense error, right? Cannot apply indexing with index and expression to IEnumerable because it's the read only. At the compile time itself, we came to know this assignment that is I'm doing, that's not a valid one. That is the invalid assignment, right? So that's the best part of this safe approach, right? Now you have understood how we can implement the safe approach while doing the covariance in the array, right? And contravariance is not supported in array in C#. Covariance and contravariance with delegates. So here we are going to see the examples of the covariance and contravariance with delegates. Okay. So covariance in C# delegates provide flexibility in the return type of the delegate method. Let's try to understand with the help of examples shown over here. So here I have defined the delegate signature that should match with the method signature. That's what I have written: public delegate parent my delegate child obj. Here if you notice, return type of the delegate is the parent class object. So here with the help of covariance, instead of parent class object, we could return child class object, and that should be fine. Okay, let's see how it works. So here we have two class, parent class and the child class. Child class inherit the parent class. Both class has one method, parent method and the child method. Now there is a class named program over here that has three methods: test method 1, test method 2 and the main method. Test method 1 accepts child object and returns the child object, whereas test method 2 accepts child object but returns the parent object. And before returning these methods, writes one statement into console window. In this statement, we are writing a static test method 1, and in this method, I am writing a static test method 2. Now there is a main method which is an entry point of this application. It instantiates the myDelegate and assign test method 1 to it in its constructor. Then making the direct call to the method via myDelegate object while passing its input parameter as a child object, and that's what I have written: obj myDelegate new child, and then we are storing into this reference of the parent class. That's what I have written: parent obj parent1 is equal to obj myDelegate new child. And then in the next statement, I am assigning the test method 2 to myDelegate object, and that's what I have written: obj myDelegate is equal to test method 2. And then calling the method via the myDelegate object while passing input parameter as a child object, right? So obj myDelegate new child, and then reference that we are going to get it, that we are storing into this obj parent2 of the parent class. So that's the program. If you are facing difficulties to understand the delegate concept, I have already created a detailed video on delegate. You may watch it to know the delegate in detail. Anyway, that's the program over here. Here, as we have seen, the delegate signature has the parent class object as a return type. But if you see the test method 1, its return type is child object. That's where covariance takes place, right? And if you see the output, we are getting a static test method 1, a static test method 2 printed on the console window. Now you have an idea how to use covariance concept with the delegate. Now let's see the contravariance concept with the delegate. What is contravariance in C# delegates? Contravariance in C# delegates applies to parameters. It allows us to assign a method with a parameter of a parent class to a delegate that expects the parameters of a child class. Okay, let's try to understand with the help of examples shown over here. So here there is a delegate signature where expected parameter is child object, right? We need to focus on this parameter where contravariance is going to take place. Now there is a class named program that has 4 methods: test method 1, test method 2, test method 3 and the main method. Test method 1 accepts child object and returns child object, whereas test method 2 accepts child object but returns the parent object, whereas test method 3 accepts parent object and returns the parent object. Now in main method, I have instantiated the myDelegate and assigned test method 1 to it in its constructor, and then added test method 2 and test method 3 also in invocation list. And finally, I have invoked all method using delegate, and that's why I wrote parent obj parent is equal to obj myDelegate new child. And if you see the output, we got a static test method 1, a static test method 2, a static test method 3 as expected. If you have already noticed, test method 3 is having parent object as an input parameter, but delegate has child object as input parameters. How did it work? It worked because the contravariance took place where it allowed us to assign a method with the parameter of a parent class object to a delegate that expects the parameter of a child class object. Okay, let's switch to the Visual Studio and see all these things in action. Here we are on Visual Studio. Here we are going to see the demo of the delegates with covariance and contravariance. So for that, I have created one console application, covariance and contravariance, that has program.cs file. And if you see, I have written this delegate signature over here. Public delegate parent my delegate child object. And if you see, the return type of this delegate is the parent object, right? And the input parameter is child object. So it's very important. We need to keep in mind this is the delegate I have written, and this is going to point that particular method that we are interested for. Okay. So now there is a class parent and the class child. This child class is inheriting this parent class. This parent class is having this parent method that basically print this statement into console window. Similarly, child class has the child method that prints this statement into this console window. Now there is a class program. We have three methods over here: test method 1, test method 2, and the main method. In test method 1, we are accepting child object, then we are returning as a child object. But in test method 2, we are accepting child object, but we are returning this parent object. Now if you see this main method, we have written this statement that I'm just giving the demo of the covariance with delegates, right? So here I have created an object of the delegate and assigned a method to it, and that's what I have written. My delegate obj my delegate is equal to new my delegate test method 1. Then I am calling this method with the help of this delegate object, and that's what I have written, obj my delegate, and here I'm just passing the input parameters as a child object to it. Method is returning that value we are storing into this parent object, and that's what I have written, parent obj parent 1 is equal to, and this the return whatever the returning is happening. And here what I'm doing, I'm just calling this method with the help of this delegate instance. So obj my delegate and new child, here I'm just passing the parameter to it. Then we are assigning to the parent object, parent obj parent 1 is equal to these things. Okay, now later what I have done, I have assigned this test method to obj my delegate, and then finally I'm just calling this obj my delegate, and here I am passing this new child as an object to that particular method, that is the test method 2. Okay, so this is the simple program. Basically, if you notice, delegate signature is having the return type as a parent object, right? But if you see the test method 1, its return type as a child object, right? And that's where the covariance is going to take place. Okay, so covariant is basically doing the implicit conversion for that. And that's how this covariance works with the delegate in C#. Okay, let me execute this and see the output. So output got appear into this console window, and this statement got printed, demo of the covariance with delegates, because I have written console.writeLine statement over here, right, as a first line in this main method. And then this test method 1 got executed, and this test method 1 is printing this statement, static test method 1, that's what it got printed. Similarly, static test method 2 got printed when this test method 2 got invoked with the help of obj my delegate. So here we are going to see the demo of the contravariance with delegates. Here there is a delegate signature where expected parameter is the child object. We need to focus on this parameter where contravariance is going to take place, and that's what I have written, public delegate parent my delegate child obj. Okay, now there is a class parent and class child. Class child is inheriting this parent class, and it has method child method that basically prints this statement into this console window. Similarly, parent class is having this parent method, and this statement got printed when this parent method is going to get executed. Okay, now there is a class named program. It has four methods: test method 1, test method 2, test method 3, and the main method. Test method 1 accepts child object and returns the child object. That's what I have written, new child return over here, right? Whereas test method 2 accepts child object but returns the parent object. And test method 3 accepts parent object and returns the parent object. Now in main method, which is an entry point of this application, I have written this statement, demo of contravariance with delegates, because I'm just giving the demo of the contravariance with delegates, right? Here what I have done, I have created an instance of this my delegate and passed this test method to its constructor. So that's what I have written. My delegate obj my delegate is equal to new my delegate test method 1. And then what I am doing, I am adding this test method 2 and test method 3 in the invocation list. And finally, I have invoked all method using the delegate. That's what I have written, obj my delegate new child. And then whatever the return output is coming, that we are storing into this parent obj parent. Okay. You must be thinking where the contravariance is happening, right? So if you notice this test method 3, where input parameter is the parent object. But if you notice delegate, where the input parameter is the child object. And that's where this contravariance is happening. Because the contravariance allowed us to assign a method with the parameter of the parent class object to a delegate that expects the parameter of a child object, right? Okay, now let's execute this program and see the output. Okay, so output got appear into this console window. Demo of the contravariance with delegates got printed, and the static test method 1, test method 2 and test method 3 got printed from the invocation list, in which order we have added into the delegate, right? So that order it got executed and then it got printed into this console window. That's the demo of the contravariance with the delegates. Now let's move to understand covariance and contravariance concept with the generics. Covariance and contravariance with generics. So here we are trying to understand the covariance and contravariance concept with the generics. So covariance in C# generics provides flexibility to use a child type than originally specified. Okay, let's try to understand with the help of examples shown over here. So an instance of the IEnumerable child can be assigned to a variable of type IEnumerable parent, and that's what I have written. IEnumerable child obj child is equal to new list child IEnumerable parent obj parent is equal to obj child. So that's how this covariance is happening in the C# generics over here. Now contravariance. Contravariance in C# generic provide flexibility to use a parent type than originally specified. In covariance use a child type. Here we are using a parent type than originally specified. And if you see the examples, an instance of the action parent can be assigned to a variable of the type action child. And if you see here, action delegate with the lambda expression I have written over here. So action parent P is equal to target, and then I'm writing console.writeLine target.get type name, and then here what I'm doing, action child C, and here assignment I'm doing. So P I'm assigning to the action child C, and then I'm just calling this C and passing this new child object to it. That's how this contravariance in C# generic happens. Okay. Okay, let's switch to the Visual Studio and see these things in action quickly. Okay, so here we are on Visual Studio. Here we are going to see the demo of the covariance and contravariance with generics. So for that, I have created one console application, that is covariance and contravariance. It has program.cs file. In program.cs file, we have two classes, parent class and the child class. Child class is inheriting this parent class. This parent class is having one method, parent method, and child is having the child method, and these two statement is printing when this method is going to get invoked. Okay, now there is a class named program that has main method, which is an entry point of this application. Here I have written this console.writeLine statement because I'm just giving the demo of the covariance and the contravariance with generics, and I just want to print in this console window. Okay, now I have written this IEnumerable child obj child is equal to new list child, and IEnumerable parent obj parent is equal to obj child. So here basically covariance is happening, right? So let me put the breakpoint over here, and I have already put the breakpoint over here, right? I have written this action parent P target console.writeLine target get type dot name. So this statement is nothing but the action delegate I have defined with the lambda expression. And then action child C is equal to P. Here assignment is happening. So this assignment basically what is happening, contravariance is happening because we are assigning parent to the child, right? And then finally I'm just invoking this action delegate where we are passing this new child object. So basically why I put this breakpoint over here, I just want to show you while debugging. So this statement is getting executed successfully. Okay, let me execute this program and see the output. Okay, now if you see this breakpoint got hit, right? So this statement has not executed yet. Let me go and click a step over. Okay, so this statement got executed successfully. So basically this covariance passed successfully. So covariance happened and we are able to successfully, assign this obj child to the obj parent. Now I have control in this action delegate itself. Let me go and click again a step over. So yeah, this action delegate got created. And then what I'm doing, then I have done this contravariance assignment also. So that is also successfully passed. Now I'm just going to execute this. So if you see, this child got printed. How this child got printed? Because I have passed this new child object over here. So that is the target. And here what I'm going to get it, target.getType.name. So I got the target name and that is nothing but the child. So that's what this child got printed over here. So that's the demo of the covariance and the contravariance with the generics. Now that brings me to end of my session. To sum up, in this video, we first understood the parent and child relationships, then learned what covariance and contravariance are. Post that, we saw covariance and contravariance applicability with arrays, delegates, and generics. Now you are familiar with the covariance and contravariance knowledge, and you can decide between these two based on the type of data you are working with, right? That's all for this video, guys. If you like this video, hit the like button, share it with your friends and colleagues, subscribe to my channel if you haven't done already. Thanks for watching. See you next video.